Welcome to today's video. In the biochemical calculations playlist of this channel, we are seeing about the different ways in which concentrations of solutions may be expressed. Last video we saw about percent solutions, which is one of the simplest ways to express the concentration of a solution. In today's video we will see about how concentration can be expressed as molarity and molality. To understand molarity and molality, we have to understand the mole concept. Mole is one of the important ways in which the amount of a chemical may be expressed. It is significant because 1 mole of any compound, whatever be the compound, will contain 6.023 into 10 power 23 molecules, which we call as the Avogadro number. Similarly, 1 mole of any element will contain 6.023 into 10 power 23 atoms, and 1 mole of any ion will contain 6.023 into 10 power 23 ions. Now, what is a mole? Mole is the weight expressed in grams divided by the molecular weight. So we can find out the number of moles of any compound if we know the weight of that compound in grams and we divide it by the molecular weight. This formula is very useful for us to convert a particular weight to moles or to convert moles into weight. We have this formula and you can find out. Similarly, for an element, it will be weight in grams by atomic weight. For an ion, it will be weight in grams by ionic weight. From this formula, we can find out that if we need 1 mole, the numerator and denominator should be the same. That means the weight should be the molecular weight expressed in grams. So if we are writing the molecular weight in grams, that will be 1 mole of a particular compound. This formula will be useful to us when we are doing the calculations for molarity and molality because it is simpler to do it with this formula. So here we can therefore write 1 mole as gram molecular weight. That means molecular weight expressed in grams, because if these both are same, the answer will be 1 mole. Similarly, for an element we can write 1 mole is gram atomic weight, or for an ion 1 mole is gram ionic weight. Now let us see the definition of molarity. Molarity is the number of moles of the solute per liter of the solution. So how many moles are there in 1 liter of the solution? That is molarity. Keep in mind it is the whole solution and not the solvent. It is denoted by the capital letter M. Sometimes it may also be written as moles per liter or mol per liter. Molar concentrations are usually expressed in square brackets. We will now see how to prepare molar solutions. So in a lab, this is a situation which we will always come across. We know the volume of a particular reagent that we want and we know the concentration. So suppose I need 500 ml of a 0.5 molar solution, then how much should I weigh and dissolve? So if in this particular case we are talking about sodium hydroxide. So how many grams of sodium hydroxide should I weigh and dissolve in 500 ml to get a 0.5 molar solution? So whenever we have such a case, you have to write the standard equation. 1000 ml of a 1 molar solution will contain 1 mole. We know 1 molar solution is 1 mole per liter. We have seen the definition. So instead of putting it as 1 liter, I am putting it as 1000 ml. So 1000 ml of a 1 molar solution, here instead of writing it as 1 mole, I am putting it as gram molecular weight, as I have told first slide. So it is always easy when we do calculations to put it in terms of grams rather than in moles. Of course, the calculation can be done in that way also. But here I am making it simple by putting the weight as gram molecular weight, which is 1 mole. Now I need 500 ml, 0.5 molar. So how much should I weigh? So this is X. The only thing we have to remember is we have terms here. So this pattern of cross multiplication we have to follow. So x will be 500 into 0.5 into 40 divided by 1000 into 1, which is 10 grams. Now, to know the molecular weight of a compound, if it is in a lab when we are working, we can easily just check the molecular weight in the bottle and use it as such. That is the best way to do it. But if it is a numerical problem, then if we know the molecular formula and if we know the atomic weights of some important elements, you can add and you can find the molecular weight. So molecular formula of sodium hydroxide is NaOH. So sodium is 23, oxygen is 16 and H is 1, so it is 40. In case the compound is little bit difficult, usually if it is a numerical problem, they will give the molecular weight which we can use it as such. Now, in a numerical problem, this can also be X. Like they can give you how much is the weight and it is dissolved in so much solution, then what is the molarity? So this can also be X. Similarly, you can even find out, if you know the molarity and if you know the weight, you can even find out the volume of the solution in which it has to be dissolved. So either of these can be X in a numerical problem, and the same pattern we have to follow to find out what is X. The next one. Here, now we have to find out the molarity. So what is the molarity of a solution prepared by dissolving 42 grams of sodium bicarbonate in 250 ml water? Again, we have to write the standard equation. If it is a 1 molar solution, it will have 1 mole in 1 liter. So I put it as 1000 ml of a 1 molar solution. As I told you, instead of putting it in moles, I have put it as gram molecular weight, which is molecular weight expressed in grams. Molecular weight of sodium bicarbonate is 84. So I have put it as 84 grams. Now the weight given is 42 grams and the volume is 250 ml and we have to find out the molarity. Therefore, X will be equal to 1000 into 1 into 42 by 250 into 84. It is a 2 molar solution. We'll move on to molality. Molality is the number of moles of the solute per 1000 grams of the solvent. Remember, here it is the solvent, not the whole solution. 1000 grams or 1 kg of the solvent. It is denoted by the small letter m. Molality is often used in physical chemistry calculations like boiling point elevation, freezing point depression, etc. We will now see a problem for molality. So the same thing, suppose we have to prepare a molal solution and we 500 grams of solvent we need to prepare this and it is a 0.5 molal solution. Then you will put it as 1000 grams molal solution. Again it will have 1 mole. So it's 1 molar, it is 1 mole in 1000 ml if of solution. If it is 1 molal, it is 1 mole in 1000 grams of solvent. So here also I have to put the mole. So instead I am putting the gram molecular weight. For sodium hydroxide we have already seen it is 40. Now we know the solvent 500 grams and we know the molality. Therefore, we are able to find out what is X. 500 into 0.5 into 40 divided by 1000 into 1. The next problem, as I told you previously, this can also be X, this can also be X. So in this example, we will see how to find out how much amount of the solvent we have to dissolve. So in this case, it is potassium hydroxide and we have 112 grams. We need a 4 molar solution and how much grams of the solvent should we dissolve. So we know 1000 grams of a 1 molar solution will contain gram molecular weight. Instead of 1 mole, I am putting that. And 1 mole is 56 grams. The gram molecular weight is 56 for potassium hydroxide. So I am putting it here. Now I have 112 grams and 4 molar solution is required. What is X? Again, X will be 1000 into 1 into 112 by 4 into 6, which is 500 grams. So this is the way in which molality and molarity is expressed. Thank you.